Okay, these last rules for factoring are special cases for factoring. And I'm more interested in whether or not you can, once you figure out the formulas, whether you can put the data back in the formulas rather than memorizing these terms. So what I need you to do is I want you to write down these two rules right here for factoring perfect cubes. I'm going to come back to those, and I'm going to skip down here to factoring difference of squares. When we factor difference of squares, and you're going to want to write down all of these three different types, just copy all of these down. But when we're factoring the difference of squares, we are going to notice that if I'm only factoring two terms, the first and the last terms happen to be perfect squares, then it's going to factor into the square root of the first term, a plus b, and a minus b. So let me let you know how to find a and how to find b. You take a is going to be the square root of a, b is going to be the square root of b. And in this case, it's the square root of a squared and the square root of b squared. So let's look at an example. If I were to say, well, what is the square root of a squared? The square root of a squared is really just the square root of a times a. And remember, when we take the square root of something, we're looking for things that occur twice. So if it occurs in a pair, we can take it out and it comes out as just a. For example, if I wanted to know the square root of 4, that's really 2 times 2. And since we're taking the square root of something, we're going to take it twice, and we take it out as 2. Okay, so when we take the square root of a letter, so in other words, the square root of a squared, it gives me back a. Once we know what a and b are, we take them and we plug them in to this formula right here. It's just a plus b and a minus b. So let's practice that in this example. We want to know, what is the square root of 4x squared? Well, the square root of 4 is 2, and the square root of x squared is x. So in other words, this 4x squared, when I take the square root of it, it turns into 2x. I can do the same thing for b. The square root of 81 is 9, and the square root of y squared is y. So I can rewrite this using our formula above. It's just simply a binomial times a binomial. We write the first term plus the last term, and we rewrite it again, the first term minus the last term. And that's the answer. It's pretty quick. And what should clue you in to use this is the fact that I only have two terms, and both of my terms are perfect squares. Now I have another option down here. This is called perfect square trinomials. Here I have a perfect square at the beginning and the perfect square at the end, but I have three terms. That's why it's a trinomial. And this is just a fast way of factoring. But what I want to be able to see is if I have a perfect square at the front and a perfect square at the end, and I multiply those together times 2, I would get a middle term. Let me just show you what I mean. Here I have an example. 4x squared plus 12x plus 9. I notice that the first and the last terms are both perfect squares. Well, the square root of 4x squared is 2x, so that's my a. b is not, the square root of 9 is 3. If I were to multiply 2x times 3 off to the side, I would get 6x times 2, I get 12x, which is that middle term. So this is kind of something where with practice you will begin to recognize it. But I can quickly factor that into 2x plus 3 quantity squared, because that's what that formula tells me to do. It's just a plus b quantity squared. And we did cover this when we talked about polynomials, where if we had a polynomial like this, and we were multiplying it, we would square the first, double the product, and square the last, which is what we ended up with right there. So this example right here, the perfect square trinomials, you can factor those using grouping, trial and error, or this quick method where you have to recognize something about the first and last terms. Now I want to go back up here to factoring perfect cubes. Perfect cubes will come in the form of a cubed plus b cubed or a cubed minus b cubed. Once again, I'm looking to factor something that only has two terms, but when I look at this, I happen to notice that the first and the last terms are perfect cubes. So you're going to need to recognize cubic numbers. I would suggest that you learn the cubes from 2 to 5. 2 cubed is 8. 3 cubed is 3 times 3 is 9 times 3 is 27. 4 cubed is 64, and 5 cubed is 125. And that's a pretty good place to start. You're also going to know that this example is going to factor into the above rule because each of my exponents or each of my variables is raised to a cubic power or is raised to the power of 3. So that's kind of another big hint. So let's tackle this and see how it's going to break down. I know that the first term, a cubed, well, the cubed root of a cubed is a. Right? I have 3 of them, and when I break it down, I'm going to end up with 1. If I take the cubed root of a cubed, the cubed root of a cubed is a. So in other words, the cubed root of, on the b term, the cubed root of 64, well, we've said that that's 4. And then y, we only have one of them. Y, the cubed root of y cubed is y. That's a tongue twister for you. Mouthful. Okay, so here I have my a and my b terms, and I'm going to plug those in because this is a plus sign. I'm going to plug it into the first formula. So I just simply write this as my a term plus my b term, a plus 4y times. I'm going to take my a term here, which is a, and square it, a squared. Now I have a minus sign. The next term here is a times b. So if I multiply this a times b, I get 4ay. Okay, that's just multiplying this term by this term. And then I'm going to square. I have a positive sign, and I'm going to square 4y. Well, 4 squared is 16. Y squared is y squared. And this is the answer, this binomial times this trinomial. And you leave it like that. Notice that there are no factors of 16 that are going to add to give me 4. So that's how come I know I'm done. This is kind of a long polynomial, but you just need to be able to break it down and plug it into the formulas. So these last 3 cases are special cases, and I suggest you write them down on a note card. You're not going to be asked to memorize them, but you are going to be asked to be able to use them. To end our discussion of factoring, you can go and look at this graph right here. Either here, you can stop the video and copy it down when we're done, but it is also in the book on page 402. And it kind of walks you through which method you're going to use. Of all of these methods we talked about for factoring, the first thing you want to look at is, are there any greatest common factors that I can take out? Then you want to look at, well, am I looking at something that only has 2 terms? If so, is the first and the last term perfect squares? Maybe there's 3 terms, but my 3 terms have a perfect square at the front and the back. Okay? Otherwise, you want to use some of the other methods. And then last, you want to also, make sure that if there's 4 terms, you're going to solve it or factor it by grouping. So this is kind of a summary of how to use all of the things that we've learned so far.